This video will cover investigating monomials, and this is also a lesson that we cover on Friday, November the 13th, with third and fourth periods. So if you were not in class and you belong to those classes, please watch this video. Also, if you are from 5th or 6th and you were absent on Thursday, November 12th, please take the time to watch the video and also pay attention, take notes. And this paper will become your second homework because we do not have the online passwords for the Alex online homework system. So this will be your homework 2, and your homework 1 will be the paper titled Exponent Practice 1 that we started working with on Monday for A days or Tuesday for B days. So let's go ahead and write down some terms, some definitions here. So I know that, you have, most of you have Dr. Carrillo. So what does that prefix mean? Mono.
One.
Only one, right? So when we say monomial, what we're saying is that there is only one term. And what we have here are examples of terms. Some are just numbers by itself, and others have numbers and one multiplied by one variable. Others are a number multiplied by more than one distinct variable. So let's go ahead and write down what monomials can include. So they can include numbers. They could also include variables. And they could also include the product. Remember, we already established that means the multiplication of numbers and variables. So those are all examples of monomials. We're going to do something with those in a minute. So now let's see what will make a term not be a monomial. So for example, here it's pretty obvious. You could see there's a plus and a negative, a positive and a negative sign in between terms. So in this case, it will not be a monomial. These two are actually binomials because they have two terms. So this will be the first term and the second term. And so same thing here, one term, second term. So what monomials cannot have is any addition or subtraction. In other words, you cannot have a positive or negative signs in between the numbers and the variables. Now let's look at the next two, and we have here an x that is part of the denominator. So if we were to convert that to an exponential expression without having the x on the bottom, and if you remember or if you look at your notes from last class, the reciprocal property will tell me that that is equivalent to 9x to what power? To the negative 1. To the negative 1. And so, because of that, this type of expression, when the variables are in the denominator, they're actually called rational expressions, and those are not monomials. Now, the next one is x inside the square root. So that is actually called a radical expression. If we convert that to an exponent, it will be x to what power? So when you have roots, they have that little number called the index. In this case, it's a 2 because we call it the square root. And so to convert that to an exponent, it will be 1/2. So that index becomes the denominator. So what we're going to say here is that monomials cannot have variables in the denominator. In other words, we cannot have expressions with negative exponents. And also, monomials cannot have variables under a radical. So, example, the square root, the third root, the fourth root, or so on. Or, if we change that to exponents, it will be the same as saying monomial cannot have exponents as fractions, because that will imply that you're taking some type of root, and we call those radical expressions. Now, what about this one here, guys? We have the square root of 5. Why do you guys think that's still a monomial? Because it's not a variable. Very good. So that it's not a variable. So remember what we said here is variables under a radical. So if the number is under a radical, it's still okay. It's a monomial. Now, those type of monomials, the ones that have no variables, they actually have a special name. And that name is a constant. So that will be just a single number. So I want you guys to look at the examples that you have here. These are the monomials. And I want you to tell me examples of monomials that are just constants. Okay? So, Mr. Jordan, tell me one.
Square root.
The square root of what? Okay, square root of 5. That's good. Mr. Hanks? 2. Destiny? 0. 0. Samantha?
Negative 8.5.
Negative 8.5. And I'll do the last one, 5/3. So those are just constants because they're numbers with no variables. They're still monomials. What is the degree of those monomials? You guys remember?
0.
0. Degree 0. Okay, so let's move on. In a monomial, the blank is the numeric factor of the variable. So that will be the coefficient. Examples of that, I will tell you, we have a term that says 2x. So I'm going to say 2 in 2x. Samantha, tell me another one.
5/3 y squared.
So I want the coefficient.
So 5/3 in y squared.
Okay, so we will say the whole thing in 5/3 y squared. Okay, Destiny?
9 in 9a raised to the 6th power, b raised to the 8th power, and c raised to the 7th power.
Very good. And we have one more. I'll do that one. So the last one will be negative 8.5 in the monomial negative 8.5 xy squared. Okay. Now let's move on to the next item, and we have the blank of the monomial is the sum of the exponents of the variables only. So we add the exponents of the variables, and that is going to be the degree. So the first example, we have 2x. The exponent of x is just a 1, so that means the degree is 1. The next one, we have a 2 for y, so the degree is 2. However, the next term, we have two different variables. The exponent of the first variable is a 1. The exponent of the second variable is a 2. So 1 plus 2 is 3. So I'm going to give you guys a few seconds to answer the questions that are on the right side. and then I will ask you, and you guys will go first, because we don't have too many options. All right, so Mr. Jordan,
Yes.
what would be the degree of this one?
12.
12, very good. So you added 2 plus 3 plus 7. And then Mr. Hay, I think you can answer both of the next ones, right? What's the degree of those constant terms? 0 and 0. All right. So remember, the degree of a constant term of a number without a variable is always 0. So let's go to the next page. All right, now we're going to review a little bit of those rules that we already went over with exponents. This is very important because we're going to start factoring, and actually factoring is like a very big part of the TSI. So what we're doing here is we're expanding, we're explaining why that rule works. And we have two terms that are multiplying each other. And if we expand 5x squared times y cubed, we get a 5, we get 2 x's, and we get 3 y's right here. Now, if we expand 4x y to the 4th, we get a 2 and a 2, because that is 4. And then we get 1x, and then we get 4 y's. So now the next step was to reorder. So we have all the numerical factors first, then we have the x's, and then we have the y's. So what is 2 times 2? That's 4. And then 4 times 5 is 20. How many x's do we have? 3. And we have 1, 2, 3, 4, 5, 6, 7 y's. So the shortcut for that, because we're not going to be expanding all the time, right? So we already went over the rules a little bit. So the shortcut is that you multiply the coefficients. So we could have just multiplied 5 times 4, and that would give us 20. And also, what do you do with the exponents? You add the exponents. Very good. So if we add 2 plus 1, that gives us a 3. And then 3 plus 4, that would give us 7. So the rule, remember, for multiplying terms or variables will be, well, for variables is that you add the exponents. So this will be a to the power m plus n. But keep in mind that the basis must be the same. Now let's look at dividing. And again, we're going to expand. So first of all, we have 18 x to the 4th, y to the 3rd. And so what you guys see here is the prime factorization of 18. So that is 2 times 3 times 3. X to the 4th, we have 4 x's here. And y to the 3rd, we have 3 y's here. Now for the denominator, we have 6. The prime factorization is 2 times 3. We have 1x, and we have 2 y's. And now what I'm going to do is divide them. So, or you may say they cancel, right? So 2 with a 2, a 3 with a 3, an x with an x, a y with a y, a y with a y. So now what we're left with is with this 3 here. And we have a total of 3 x's, so x cubed, and we have 1 y left. So 3x to the 3rd power, and then y to the 1st power. And so, of course, let's go over the shortcut here. And that shortcut will be that you divide the coefficients, and you subtract the exponents. And of course, we know that the rule for that will be a to the power m minus n. And again, the basis must be the same. Any questions? No? Okay. Now let's go over some of the rules, and let's try to do this quickly so that we can get to the next page, because those are a little trickier and more similar to what you will do on your homework. And I'm talking about the ones here and here. Okay? So we have the reciprocal property here. So that says that if you have a negative exponent, you can move that number, the base, to the bottom, and that will make the exponent positive. So this will be 1 over 5 squared. The next one will be 1 over x to the 4. And now here, what we need to do is we're dividing the variables. So what do I need to do with the exponents? Subtract. So there will be b to the power 9 minus 3. Oh, actually that's wrong, right? It should be b to the power 3 minus 9. And so b to the negative 6. So how could I make that exponent be positive?
You do the reciprocal.
The reciprocal, or bring it to the bottom, right? So 1 over b to the power 6. Now here we have this one, which is called the power rule. And so we need to multiply the exponent. So in this case, 2 times 3 is 6. So we'll have 5 to the power 6. The next one, 4 times 5, that is 20. So we will have x to the power 20. The last one for this row, it will be negative 2 times 6. So that will be b to the power negative 12. And here we need to leave it with a positive exponent, so it will be 1 over b to the power 12. So let's write that down here. No negative exponents. Okay, next one, we call this one the power of a quotient. And this one says that if you have a fraction raised to a certain power, you must distribute that power to the numerator and to the denominator. So in this case, 5 squared is 25, 8 squared is 64. The next one, we just have variables, so it will be x to the power 7 divided by y to the power 7. And here we will have b to the 3rd power, but then raised to the 5th. And then c squared raised to the 5th power. So here we remember we multiply the exponent, so this will be b to the power 15 over c to the power 10. Now let's do our next and last row for the section. And this one, it is called the power of a product. So in this case, we need to distribute the exponent to every single factor inside the parentheses. So it will be 5 squared times 5 squared to the 2nd power. So 5 squared is 25. And here, what do I need to do with the exponents there?
Subtract.
No.
Multiply.
Multiply. Multiply. Come on, guys. So think of this. If you have x squared and then to the 2nd power, that would be the same as saying x squared times x squared. So that will be x to the 4th. Well, actually, if we had added, we will get 4 too, right? But that will not be a good application of the rule. Okay, next one we have x to the 6th power and then y squared to the 6th power. So right there we cannot add, right? For sure. We will have x to the 6th, y to the 12th. And for the last one we will have 4 to the 3rd power, x squared to the 3rd power, and y to the 4th to the 3rd power. So remember here, we need to multiply those exponents. So we will have 4 to the 3rd power is 64 x to the 6 and y to the 12. I want to remind you to take your quiz on Edmodo. It will only be available until Tuesday at 11:59 p.m. And please do your homework, because if you do not turn it in by the due date, I will not accept it. Okay? All right. So let's move on to the next page. What I would like to do before those, actually you guys are going to work on those. I would like to do problems 7 and 8. So for problem 7, we have a rectangle with the width represented by 3x squared y to the 5th. So here's the width. And the length is represented by 8x to the 5th, y to the 3rd. This is the length, this is the width. And how do we calculate the area of a rectangle, of any rectangle?
Length times the width.
Length times the width. So the area for this one, and that's actually what we need to find, what expression could be used to represent the area of the rectangle? So we substitute the length with the expression 8x to the 5th, y to the 3rd, and we substitute the width with 3x squared, y to the 6th. So remember, what do we do here with the coefficients? The big numbers. You multiply them. So 8 times 3 is 24. And then with the x's, we're multiplying x to the 5th times x squared. So what do we do with those exponents? No. You add them. Seems like you guys need to review your notes. And now for y, how many y's will we have? 3 and 6? 9. So you add the exponents. Multiply the coefficients, add the exponents. All right, next one, we are given the area of the triangle. So the area is represented by that quantity there. And what we need to find is the base of the triangle. It says here, find the expression that represents here, the base of the triangle. Now, we should know the formula to find the area of a triangle, right? What is that? All right, how about base times height divided by 2? Yeah, same thing. But with triangles, we like to use the word base and the word height. So in this case, we know an expression for the area, and that is given to us here. That is 14x to the 4th, y to the 9th. Also, we know an expression for the height. We do not know an expression for the base. That's actually what we're looking for. And the height is 7x squared, y to the 5th. Just one here. We also know there's a number 2. Now we're going to solve for b, the letter that is in red that you see here. So we have a 2 dividing b. So if I want to take that 2 across the other side, what operation is it going to do? Multiplication. On this side we have b times 7x squared, y to the 5th. So here I'm going to distribute the 2 by multiplying to every variable here. Actually, only the coefficients, I'm sorry. So that will be 2 times 14, that will be 28. 28x to the 4th, y to the 9th. And now here, we're almost there. We have b times 7x squared, y to the 5th. What is b doing to the 7x squared, y to the 5th? They're multiplying each other, right? So if I take all the stuff inside the parentheses across the other side, what is it going to do? Divide, yes. So 28x to the 4th power, y to the 9th power, divided by 7, x squared, y to the 5th. And so just to finish this, it will equal 4x2, very good. So you divide 28 over 7 is 4. The x's you subtract, and the y to what power? We had y to the 9, 4. So you divide the coefficients, subtract the exponents. So I wish I had more time to go over this. I think we have about 1 more minute. Let me just show you how you will work something like this, like number 6. And please do not turn in your homework with just the answer, because I'm going to assume that you use the answer key. So before you pack your things, I want you to pay attention to this. We will have to distribute this 2 to every single exponent or factor. So we will have -3 squared, x cubed squared, y to the 6 squared. On the bottom, we will have x to the 5th squared, y to the -2 squared, and then z to the -1 squared. So because of that, we will have -3 squared, that is equal to 9. Here, this one will turn into x to the 6. Here, we will have y to the 12. On the bottom, we will have x to the 10th power. Here, we will have y to the -4th, and then z to the -2. Now, remember, we have that rule that says that if exponents are negative, we can move them from the bottom to the top or from the top to the bottom, and that will take care of the sign. So we will have the following: 9x to the 6, y to the 12, y to the +4 for this one, and then z to the +2. Still, we have x to the +10 down here. Now, from here, I need to make some space, so I'm going to erase this part. We could combine the y's. And that will be y to the 16th power, since I added the exponents, and then z to the 2nd power. Now, if you notice, we have x to the 10th and x to the 6th. So if we were to subtract on the numerator, we will end up with x to the -4. So what I'm going to do is actually subtract on the bottom, and it will be 10 minus 6, and that will be 4. Okay? So that is a way you can work out that problem. Remember, whatever we didn't cover, it is for you to do as homework. So this is the end of the video.